of z, complex number. All right, let's say you have your, all right, y, this is x, this is theta, that is r, and you've got y here, of course, and x there. Let's say this is your complex number in the x or y plane, right? And from here we know that cos theta is just equal to x over r, and we know that sin theta is equal to y over what? Over r. These are known. What if we make x the subject of the formula? We get r equal to cos theta. All right, and we make y the subject of the formula. We make r sin theta. In polar form, we are only interested in r and theta. In polar form, take note. In polar form, we are only interested with r and cos theta. So we are going to make sure that we get our r and our theta out of there. Are we there? Now we know that a complex number is given by x plus what? Iy. You know this complex number equation, right? And from here, what is our x? Our x is r cos theta plus what is our y is r sin what? Sin theta. Take out r because it's common. So I've got cos theta plus I there. So there will be I here. I sin what? Sin theta. This is complex number in polar form. You see that it's difficult. It's simple to derive. While theta is the argument, all right, and r is the modulus. Let's look at an example. Can express this one in polar form. In polar form, number 1. I've got z is equal to 1 plus I. Simple. Let's express. We know that in polar form it will be r cos theta plus I sin theta. You get it? So let's find r. R is a modulus. So we square that one. We square 1, which will be what? Root of what? 2. And we need to find the angle. The angle cos theta is equal to x over r, which is what? 1 over root 2. Sin theta is equal to y over r, which is also 1 over root 2. And I think from the previous example, we found the theta to be pi over 4. Now that we know what pi is, so what theta is, our r is just root of 2. Then open bracket, this is cos what? Pi over 4 plus I sin pi over 4. Done. Example 2. So for this one, let's find the r. R is negative 1 squared plus 1 squared over the root is just equal to root of 2. Now let's find the angle. Cos theta is equal to x over r. X is that, right? Over root of 2. And sin theta is equal to y over r. Okay? And what did we say about y? Y is just 1 over root of what? 2. I think we found something like here. Alright, even if we didn't, this is just like pi, right? Or this is just pi over 4. Because this complex number, you're actually going to find it where? In negative 1 there, and in 1 somewhere there, in the second quadrant. And in the second quadrant, how do we find the what? The theta. Alright, we just say pi minus the reference angle. So theta is equal to pi minus the reference angle is what? 45, right? This is just 45, like pi over 4. All right, good. So you can say this minus pi, just the same. So we've got pi over 4 minus this one, which is this and this, negative 3. We can do this just the same. Pi plus this one. This is pi. Now the angle is minus, right? Because there's negative there. So pi over 4. Because when we look at here, sine is positive, cos is what? Negative. So we have that will be 3 pi over 4. That's our angle. Then we have z is equal to r cos theta plus I sin theta. So this is our theta. Z is equal to root of what? 2 cos 3 pi over 4 plus I sin 3 pi over 4. Just be careful how you are getting these arguments. I know you've got problems. If you've got problems triggering, I don't know, but yeah, this is the argument, because in the second quadrant we just say pi minus that same argument. That's how we say it, minus the reference angle, for you to get that. You know these rules. Yeah, done. Let us evaluate the product of two complex numbers. Now, whenever you are multiplying two complex numbers, you divide their modulus, then you add their arguments. So you have to convert this. If you want, you can direct multiply this, then you get their answer at the end of the day. It's up to you. All right. Now, what if I say, let me not say evaluate, but I say express in polar form. All right. So to express one in polar form, like I said, if you want, you can multiply, then you get a single complex number, or you can independently, do them. It's still the same. Okay. So if you multiply this, or you express this one as a polar form and this one in polar form, you are still going to get the same answer. All right. So let's take this one. All right. Right, for this one, let's call it modulus 1. Let's find the modulus for this one. The modulus for this one is just I squared, right? I is 1 squared plus 1 squared, which is just root of what? Root of 2. Now let's go to R2. R2 is just the modulus of this one, which is just what? Root of 3 square plus 1 squared over the root, which we know give us root of what? 4, and that will give us 2. All right, now let's find the angle. Let's call it theta 1. Cos of theta 1 and sine of theta 1. Now this is x over r, this is y over r. And this is 1 over root of 2, and this is 1 over root of 2. And we said this is just theta is equal to pi over 445. So we can express the first complex number, let's call it z1, is equal to root of 2 cos pi over 4 plus I sin pi over 4. So we've done for the first one. Let's do it for the second one now. The second one, we've got cos theta 2 is equal to x over r, and sin what? Theta 2 is equal to y over r. And this one, we've got, what's our x in that case? Our x is root of 3. Our modulus is 2. And then we've got negative 1 over 2. And I think we found this. And theta is just pi over, this is just what? 11 pi over 6. Now we know that this is theta, right? Or negative pi over 6. So these are the two angles. So we need to express one into polar form now. So the first one, all right, so we have, so z2 is equal to 2 cos pi over 6. Well, we know that we can use pi negative or this one, the answer will still be the same, right? And because it's negative, then that even if I put negative here, cosine will still remain the same. But for minus, for cosine, for sine, it will be a minus. Sine pi over 6. Because sine is odd, so the negative here to come out. Or z2 is equal to 2 cos pi. Why do I keep on saying pi? Cos 11 pi over 6 plus I sine 11 pi over 6, like that. So now we know that it's either we are multiplying the first one and these two, or it doesn't matter. So we've got z1 and z2. What do you have here? So we have the first one, and we know that it was root. We multiply the arguments and 2, this. Then you multiply the modulus, then you add the arguments. All right, so we have the first one there, it was pi over 4. All right, and the second one here, we have, it's just pi over 6. But we know that if you want this one here, we know that it's just pi over 6, right? Now, we know that from the word go, there was a negative, right? From the word go, there's a negative part. So, this will just be equal to cos. The first one was what? Pi over 4 minus pi over 6. I'm doing this one and the first one. Now, why am I putting a negative despite this one being positive? It was negative in the first place. And the plus I sine. Alright, then we have sine, and I'm still using this one. We still have got pi over 4 minus pi over 6. Good. Alright, then we can now say this is just 2 root 2, and I'm going to get cos pi over 12 plus I sine pi over 12. You can also do the same for this one and the first one.